Hello everyone. Our today's topic in CAD CAM is group technology. Group technology. In short, we call it as GT. How does it help? Group technology help the manufacturing process in many ways, where with the help of this particular group technology, we can improve productivity and we can reduce the lead times, setup times. There are many advantages related. If you talk about the basic advantages of this particular group technology, mainly our focus is to improve the productivity has to be improved, and in process inventory costs should also come down. Okay, mainly if you talk about, and for example we'll try to talk about the advantages followed by the applications and how to implement group technology. Okay, in a sequential order I'll try to explain each and every point. Just try to focus. Okay. Firstly, whenever you talk about any of the system existing in any of the organization, what are its goals? That is more important. Okay. Group, what is the goal of a group technology? To improve maybe manufacturing lead time. If you would like to reduce the manufacturing lead time, that is your first goal. Okay. Similarly, reducing work in process. These are all the goals related. Reduce setup time, reduce tooling time, and fixtures time. All these are the things need to be noted. Now in general, group technology is nothing but a manufacturing sequence. It is a manufacturing sequence where similar parts are identified. GT, I'll just make a point here. GT is nothing but manufacturing philosophy, what we call. It is a manufacturing philosophy in which similar parts are identified and grouped. Similarities, just by looking at the part similarities. Part similarities, we can group them or we can identify them. We'll try to identify based on these similarities. Okay. For the design and the production sequences, this process can also be in this particular process, not only this particular part similarities, by looking at the manufacturing sequence also we can group the parts. By manufacturing sequence also you can group the parts. Now this will help you for further processing of the production. Okay, similar parts are arranged in part families. Now if there is some similarity in parts, that will try to arrange in part families, and those part families are identified with some coding system. Under these part families you might have different individual parts or a specific part file. Okay, even that is identified with a coding system. Now how to give coding to a specific part, that we'll discuss in our further discussion. More or less this is the thing. It is a manufacturing philosophy, that what you call. Okay, to identify similar parts and group them together and give them a code, whether it is a part family or it is a simple part. Okay, now how you implement group technology. The first point to be noted whenever we talk about group technology, whenever we talk about implementation of GT, group technology. Now this can be done by two major tasks, what you call identifying part families and rearranging product machine into cells. That are the 3 points need to be noted. Number one, identifying part families, you can call it as identifying part families. Number two is rearranging production machine cells. Okay, identifying part family, this again the way I have said, it all depends on the coding. Okay. So for example, we make consider some 10,000 different parts. Reviewing all the part drawing, grouping all the part families in a substantial task consumes significant enough time. For example, that many number, for example we have some 10,000 different parts which need to be identified all the time is not possible. It will take more time. Okay, enough time to do so. So each and every part is identified with respect to their coding. Other than this, rearranging production. Okay, maybe this is also time consuming and costly at the same time. Both of them, time consuming and costly. Maybe rearranging the machine in a shop floor may also take much time consuming as well as cost effective. Time consuming and cost effective. So that is the reason most of the small scale industries will not afford to implement group technology in the firm. So here the thing is time consuming, cost effectiveness. Still you can implement it, but the thing is it costs more. Okay, if you talk about the benefits also, if you talk about the benefits of group technology, if you take, now main aim is to increase the productivity. Okay, here to firstly the main aim of group technology is productivity. productivity improvement is the first task. Okay, and lead times, reduce lead times. Okay, setup times maybe. Okay, this also comes under goals of that particular term group technology, the main goals or benefits. You can call it as goals also. Productivity improvement, lead time improvement. Okay, reduce manufacturing lead time. Okay, manufacturing lead time, nothing but total time, call it as total time, can easily be reduced by using group technology. Okay, so that we can dispatch the required product to the customer. Okay, and work in process, we need to reduce work in process also. Now other words, we can reduce, in process, from machine to machine, whatever the process going on till it reach the assembly region. So in process, in between, we can reduce the time, and we can improve the scheduling also. We can improve the scheduling of that. Now improving scheduling, nothing but taking similar products and process them in same system. Similar products and process them in the same system. Process in same system. This is the meaning of this particular scheduling. Similarly, reduce setup time, reduce tooling time. Okay, this is, which is a very much important task. With this, like I just mentioned here, reduce setup time and maybe reduce tooling time. With this, what happens? If the tooling time comes down, obviously the production rate will increase and production time will also come down. Similarly, setup time, okay, tooling time, then scheduling, work in process, and total time of the product. Okay, all leads to productivity improvement. These are all the times points need to be noted carefully, which will help you out. Okay, in general practice, this particular group technology, what we are talking about, will help in many ways. Okay, in these many ways. Okay, other than this, how to implement group technology in the firm? What are all the changes that we could see in a manufacturing industry with the implementation of group technology? With the implementation of this particular group technology, complete layout of shop floor will change. Okay, if you look at, we'll try to focus on two different flow charts, all the shop floor layouts. Okay, I'll name it as process layout. First one, I'll just name it as process layout. Secondly, I'll name it as group technology layout, or else group technology process layout. Okay, means this before group technology, we used to have only process layout. Okay, so how the shop floor used to be in those days, like for example, if you consider the complete space of shop floor, this has the complete space of shop where you need to place all your machines for a specific work to perform. Under this, now we have different departments. Maybe the departments are arranged something like this with some cabinets, all right, something like this, partitioned. And under this, if you could see, first one, let us call it as lathe, milling, and maybe drilling, grinding, a sub-assembly zone, and a main assembly. These are the different departments. And here in this case, if you talk about all the departments, the machines are arranged something like this. These are all the lathe beds placed. Okay, different lathe beds, different milling machine beds. Okay, now the arrangement of these machines are made not with respect to any simple criteria or any simple calculations. Now based on the space availability, they are trying to place the machines. Okay, there is no criteria that the machine has to maintain so and so space with respect to the wall, and there should be this much gap between the two machines. No such criteria used to be implemented. Simply machines are placed something like this, available machines. Now for example, if part number 1 need to be processed, then if for example some turning is required, part number 1 will move on to lathe bed 1. Okay, if the lathe bed is completely free from any work, then it will move on to lathe bed number 1. From here, for example, some milling operation need to be performed. If all the three are vacant, if all the three milling machines are vacant, it will straight away move on to machine number 1. If not, if the machine number 1 is working on some other process, it will move on to 2 or 3. Similarly, after this, if required, it will move on to drilling. If drilling is not required, directly from milling machine 1, it will move on sub-assembly zone. Similarly, part number 2, let us consider part number 2. There is nothing to do with the lathe department, then it will move on to milling. Some work has to be performed in drilling, then in the grinding, then again to the sub-assembly zone. Part number 1 is there, 2 is there now. Similarly, part number 3, similarly part number 4. It all depends on the process, okay, and this sequential order, process 1 and part number 2, has to be done manually. The process sheet has to be developed, or root sheet has to be developed manually in case of process layout, and these machine arrangement are fixed throughout the project. There won't be any change, okay. These machine layouts, arrangements are fixed for throughout the project. If you get a new project to the organization also, the layout will not change, only process has to be changed. If for example, if all the 4 lathe beds are very much busy with the process, if some task has to be performed, then the part has to wait for the machine. That is the main criteria, where time lag is there. If all the 4 machines are very much busy with other processes, then part number 5, which need to be performed on lathe machine, has to wait for some time, which is a time lag process. So here in such case, time plays a key role. It becomes a wastage of time now. Similarly, in case of milling also, for so and so process, so and so X project, only 1 milling machine is enough, but still we are having 3 in the firm. 3 will remain same, the arrangement will not change. We will try to use any one of them which is effective, okay. And coming to drilling machine, if drilling is nowhere required to so and so X project, but still this machine will exist. So the departments will not change, machine layouts will not change, that will remain forever, and the process has to be changed accordingly. That is the main drawback here is time. Number 2, we can't even estimate few things like how much time does part number 1 will take on machine number 1, how much time will it take. Similarly, how much once it is finished, it finishes its work in the lathe 1, how much time will it take to move to milling number 1. Similarly, from here to grinding, how much time it will take. Time lag will not be said in case of normal process layout. In between machines, on the machine till it reach the assembly or main assembly, sub-assembly or main assembly, that time lag differences will not be set by this particular process layout. That is the main reason. And one more problem is, if few machines are very much busy, then the part has to wait for the machine to get vacant. Till time it has to wait. That is one more drawback. Similarly, we have many more drawbacks in this process layout. So after the introduction of group technology in the manufacturing process, which we call it as a manufacturing philosophy, the complete process layout got changed. Means for every project there is a different process layout for each and every project. For example, same shop floor can be designed in this way. Same space, same shop floor can be designed something like this. For example, complete shop floor for a manufacturing sequence, if you consider this complete thing as raw material, tooling, fixtures, and maybe machines, procurement or manpower, whatever. After receiving everything, based on the process planning, we'll try to set the machines first, okay, based on the process planning, okay. If some 2 lathes are required, 2 lathe machines are required, only 1 milling machine is required, 2 grinding machines are required, okay. This lathe 2, milling 2, maybe grinding 1, okay, maybe slotting machine 1. Now this arrangement or this count number will be given by process planner, which is done by a software, computer-aided process planning, and the order of positioning the machines is also set by process planner only, computer-aided process planning, okay. Accordingly, we will try to place the machines. If required, parallelly some work has to be performed, means parallelly also we will try to place the machines, okay. And this arrangement will change from project to project, it will not remain same, complete layout will change, okay. Raw material, once raw material procured, what are all, for example, the first one we call it as, maybe first is a lathe machine, followed by there is a drilling machine, there is a grinding machine, there is a milling machine, one more grinding, one more lathe. Parallelly 2 works can be performed at a time. Unless these 2 perform, it can't move to the next level. Similarly, you have sub-assembly zone, okay, followed by main assembly zone, maybe this is the main assembly zone, then here comes shipping. So the order is going to be something like this. If this is the case, then you have a clear picture that part number 1, for example, there are part number 1 to so on some part number 10 parts need to be produced, 10 different parts need to be produced with different processes and operations. Now part number 1 may move on to lathe 1. After that, what is required, that is set by process planner, which is computer aided process planner, without which group technology is nowhere useful. Then maybe if required we'll move on to milling, then maybe on to grinding, then to the sub-assembly, part 1. Similarly, part 2, parallelly it will work on lathe, maybe drilling, maybe to the sub-assembly. Part number 3, maybe to the lathe, from lathe to grinding, then to the sub-assembly. Okay, similarly part number 3, to the drilling directly, then to the grinding, then sub-assembly zone. Now once all the parts produced in the sub-assembly zone, then we will take on to the main assembly to assemble the parts and to the dispatch. Okay, this complete layout will change. Okay, I'll write it down here. Layout change based on project, or based on CAPP, computer aided process planning, and this is how we'll do. Okay, now the process layout got changed completely after the introduction of group technology. Now the part families are fixed also. Part families can also be fixed. And one more important point here is, whenever we talk about group technology, we were discussed about identification and similarities. Now this identification similarities can be done, or group technology can be implemented by using 3 different methods. The methods are: number 1, visual. Number 1 is visual. Number 2, product flow analysis. Number 3, code and classification system. Okay, code and classification system. There are the 3 ways. By using any of these 3 ways, we can implement group technology. Visual inspection, nothing but just by looking at the photograph of a specific component, we can fix which family does the part belongs to, or else by looking at the physical component also we can fix does it belongs to family number 1 or 2. Okay, it all depends. Visual inspection. But whenever we talk about visual inspection, it is not so accurate, because our naked eye can't be correct all the time. So here it is less accurate. Okay. And that is the reason we don't implement much of visual inspection or visual method. Okay. Then product flow analysis based on the sequential operations. Okay, for example, 2 or 3 parts are going through almost similar kind of flow process. Based on that, you can't fix the family of that particular part. But in case of product flow analysis, based on process only, based on flow process, means from milling to lathe bed, maybe from lathe bed to grinding machine, then to the sub assembly. If 2 or 3 parts going through similar processes, then we'll try to fix it in one family. That is one of the way again. And the most popular one is coding and classification. This is the most popular one. Coding and classification will help you in many ways. So our discussion is going to be more on code and classification in the further upcoming lectures, because this code and classification not only for the family, we give coding not only for the family but also for each and every specific part, saying that the part is a symmetrical part or a linear member or a non-linear member, it belongs to fasteners, it belongs to some other components family. So that will fix based on code and classification system, and design and manufacturing attributes also. Okay, this is again code and classification broadly classified into types. Again, that we'll discuss in the upcoming lectures completely about coding and classification system, which is very much important. In this process of coding and classification system, person called Hoppies, H-O-P-S, he has come up with a very good concept, like with some 9 digits, 1 to 9 digits, out of which 1 to 5 talk about design attributes, then rest of the things talk about manufacturing attributes. That we'll discuss in the upcoming lectures. Complete thing about Hoppies technique, and we have some code techniques, some other techniques also there, completely based on digits. Okay, based on digits, designing attributes, manufacturing attributes will be fixed. Okay, now this finally I just would like to conclude that group technology will help, it is a manufacturing philosophy, help you to know the similarities among the components and group them in a family, which will help you in further sequences. And group technology can be implemented if there is an existence of computer-aided process planning in the firm. There are many other benefits based on, and the process layout and group technology I try to explain in a different way, different pattern, with traditional way and group technology implementation. This is the traditional way where shop floor layout will never change, whereas this is the group technology implementation. After group technology, shop floor layout will change, and each and every part's time consumption in each and every machine, time consumption of each and every part when reaches to the next machine, and how many machines required, what are the tools required, everything is set in case of group technology. That is what I try to brief. And methods, if you talk about, there is a visual, product flow, code and classification. Code and classification is most popular among all, so our further study or further discussions are going to be on code and classification in detail, and what are the methods of code and classification also we'll see. Okay, so more or less this is completely based on geometry, shape and size of the component. Okay, we'll try to focus on geometry whenever we talk about group technology, based on geometry or dimensions, processes. Okay, likewise many other. Based on all these criteria, we'll try to fix the family, we'll try to give the coding to it so that we can retrieve it based on that particular coding system. Okay, now this is all about the introduction or the concept of group technology. In the upcoming lectures, we'll talk about more in depth about code and classification system and methods in it, who implemented it, and what are the advantages of implementing that particular code and classification system in any of the firms. That we'll see. This is all about group technology. If you have any queries regarding this particular topic or any related topic of CAD CAM, you can just comment in the box given below. Kindly subscribe and share our videos for more of the students to benefit. Thank you so much for watching. Thank you.